Hey guys, today I'm trying out Scrap Mechanic for basically the first time. I say basically only because I did mess around with the game for a little while figuring out the controls, but I haven't made anything serious yet. In this video, I want to try making a maze-solving robot. So, let's get right into it. So I'm starting off here in a flat creative world, and the first thing I do is just make a big concrete pad for me to start building on. Now I don't know if this was totally necessary, but the concrete looks better than the dirt, and also it makes it easy for me to start making a maze, or some sort of maze off of, so that I can start figuring out what functions I want the robot to have. So I just make a basic 90-degree turn like this, and realize there's already quite a few things I'm going to need the robot to do. So one of the big ones is going to be wall detection. So I'm starting off by putting down a lift, and the lift is basically like the genesis of your creation, and thus you can save things on it, and it allows you to easily build stuff too. So I have 4 I-beams down here, and this is going to be part of the body of my robot. So I put down 2 bearings, which are going to allow the wheels to spin and then wheels on them, but I realized the wheels are too close together, and they'll end up rubbing if I try to run it like this. So I also realized too I have no way of steering this. So I put down 2 vertical bearings, and the front bearings are going to allow me to rotate the wheels from side to side so I can steer this. Now I realize this is bigger than I thought it was going to be, so I also extend out that concrete pad. And I put 4 I-beams in the back, and this allows me to put on the back wheels without them touching the front wheels. So I put down 2 more bearings, 2 more blocks, and then put wheels on them, and you can see now I get the basis of a little robot. And if I delete the lift and start shoving it with my character, you can see how all the wheels rotate. Now the front wheels are rotating in a little bit too, but that's actually okay. That means I'll be able to steer them somehow. So to do that, I'm going to be using a controller block. Now a controller block can control bearings and pistons, but for this I'm only going to be using it for bearings. Now if I hook it up to those 2 vertical bearings, I'll be able to control their rotation with it, and therefore which direction the front wheels are pointing, and that'll allow me to steer the robot. So I start off just by connecting them up, and now I'm setting it to initially rotate the wheels 90 degrees, and then when it receives some signal, it'll try to rotate them even more. Now I have no signal inputting to it right now, so I just want to see how it rotates, but it doesn't have the best time, and I think I know why this was happening. So the front wheels were too close to the body of the robot, and when they tried to rotate, they would just bind up against the side of it, but the controller block just kept trying to add force to make them rotate, so it just ended up glitching out. To fix this, what I'm doing is extending the wheels off of the robot a little bit so they'll have more room to rotate and it shouldn't just rub up against the body. So you see I have that here. Now all the wheels are a block further out, and I can connect up those 2 bearings once again to the controller, and this time I'm hooking up a button to the controller. So now if I delete the lift, you can see the wheels rotate in a little bit initially, and I set them to alternate from going back and forth so we can see that rotation. And there you can see when the button gets pushed, they rotate side to side, and when you release the button, it does the same thing but in reverse. So to be able to get this to controllably steer, I deleted those initial values, or the initial turning values, and just added it so that when I press the button, it tries to rotate each of the bearings 30 degrees. And you can see when I press the button, the front wheels rotate to the side. And this was my first thought for being able to create some sort of automated steering system. And this steering is great and all, but I still need some way to be able to power the robot. And to do that, I'm going to try using an electric engine, and I'm hooking it up to 2 of the back wheels, and also I have the switch hooked up, so when I press the switch, it should try to move the car. But it didn't really seem to get anywhere in this test, so what I did is replace the electric engine with a gas engine, since the game said it was more powerful, and I just wanted to see what was happening. So now if I delete the lift and press the button, I thought I understood what was happening here. So it seemed like the back wheels were rotating in opposite directions and wasn't making the robot go anywhere. So I just had to invert the direction of one of the back bearings, and now when I press the button, you can see the car moves forwards, and it starts turning to the left. And now that I had some way to move it and steer it, I wanted to start figuring out how I was going to use sensors to make this thing automatically go through a maze. So for that, I just put a couple sensors in the front, and I just want to hook up the sensors in place of the button. So the sensors work that they'll turn on when they see something in front of them, and they turn off when they don't. So here you see as I step in front of the sensor, the car steers to the left, and also starts moving forwards. Now, I actually want the opposite of this for the most part. When the sensor doesn't see something in front of it, the car is able to move forward since there's nothing in front of it. But when it does see something, I want the car to stop. And to achieve this inverting effect, I'm going to be using a NAND gate. Now, when I only have one input running into the NAND gate, it's just a simple inverter. So the sensor is on, the NAND gate's going to turn off, and when the sensor is off, the NAND gate turns on, and you can see that here. So this should allow the car to move forwards until it sees something in front of it, and then it should stop. Now I'm building up a wall here to test that mechanism out, and I'm going to delete lift and let the car just run into it. Now that might have seemed unsuccessful, and it kind of was, but the car did stop at the end. You see none of the wheels are moving at all. But what I realized I needed to do was increase the distance the sensors can see, since they were only looking for stuff a block in front of them, and by the time they turned off everything, it was too late and the car would just slam into the wall. So I increased the distance of the sensor here, and you can see it helped, but the car still ends up rolling into the wall. And finally, what I realized I could do is switch out the gas engine for an electric engine, which is a bit slower, and this time what I did is just had the car try to steer out of the way. I didn't want to have it stop, but I realized there's a problem with my steering mechanism. Now, since the back wheels are being powered by the electric engine all the time with the same speed, they really don't want to turn. I would need a differential or something to make them easily want to turn. So to fix that, I wanted to switch out my steering for sort of a tank drive, so that each of the wheels can be controlled independently, and I can rotate about the center of the robot, and this should give me a bit more agility as well. So to make this happen, I have 4 engines, each of them powering one of the wheels, so I'll be able to turn them on and off, and directly affect what each of the wheels are doing. But for some reason, when I tried to test this, you can see here the screen's frozen. I didn't freeze frame or anything, the game literally just froze. I don't know why this happened, but eventually these stutters ended up just building up to the point where Windows just like, stop. So I don't know, again, why this was freezing, but I figured it had to do with the engines most likely, since once I deleted them, the game stopped stuttering so much. So I still liked my tank drive mechanism, but I was going to need a different way to implement it that wouldn't just freeze the game. And I wanted to add back in the controller block, but I'm not going to be using it in the exact same way I was before. I'm still going to have it hooked up to some bearings, but instead of just controlling the steering, it's actually going to be controlling the movement, or the rotation of the tires. So when I hit the button now, you can see how the front wheels start rotating. Now I had them rotating in opposite directions, so I just had to flip that. And I also increased the speed of the controller and told it to loop infinitely, so that when I hold the button, it'll continue to move backwards. And after doing that, you can see the robot starts moving backwards. Now the back wheels aren't moving yet, and that's because the controller block hasn't been told to do anything with them, so it just locks them in place. So to fix that, I just told the back wheels to move as well, and now if I give it another test, you can see the whole robot moves backwards. And finally, I'm just inverting the direction that it moves, so now when I press the button, it moves forwards. And now I wanted to add back in the sensors. So to do that, I'm hooking both of the outputs of the sensors up to this logic gate, and then hooking the output of the logic gate up to the controller block. And I'm making the logic gate a NOR gate. And what this achieves is a NOR gate turns on only when all of its inputs are off. So that means when both of the sensors aren't obstructed, it'll tell the car to move forwards. But if either of them gets obstructed, it'll tell it to stop. So here, after increasing the range of the sensors, you can see as it detects the wall, it locks up the car. So I felt pretty confident about this, but I wanted to hook up some more controller blocks to control like left or right movement. But as you see here, it seems like you can't hook up multiple controller blocks to a single bearing. So to fix this, what I'm going to do is stack 4 bearings for each wheel. And this will allow me to program 4 different movements for the robot, which will be forwards, backwards, left, and right. So after stacking those all up and then adding some wheels to the end of them, you see the car is much longer. I also decided to neaten up my setup a bit, so I put in the 4 controller blocks on top so that they weren't just hanging off the side. And then I hooked them all up to a set of bearings. So the first one I hooked up to the first set, the second controller block I hooked up to the second set, and so on. And after doing that, I also hooked up 2 logic gates like this. And they're both NAND gates, but they're hooked up to the sensor directly below them. And this creates the same effect as I showed before, so it just inverts the sensor. And now what I can do is take both the inverted sensor signals, put it into an AND gate, and have that control a forwards movement. What this means is when both of the sensors are off, or when both of the inverted ones are on, then it'll try to move forwards. And you can see that works here. When I block either of the sensors, it stops moving forwards. Now I'm putting in all the other logic gates, and I want to hook up the left movement. And for that, what I want to do is when the right sensor is obstructed, but the left one isn't, it'll be able to turn left. And similarly for the right movement, when the left sensor is obstructed, but the right one isn't, I want it to turn right. And then finally, to go backwards, there's going to be more logic involved with the backwards one specifically, but when both of the sensors are blocked, it'll try to move backwards. And you can see how that works here. So I block the right sensor, you can see the third controller will turn on. If I block the left sensor, the second controller turns on. And when I block both of them, the back one turns on. And then in each of the controllers, I just have to set how I want them to adjust how the wheels move. So right now I just have the left one set up, so now if I obstruct the gate a little bit, you can see how the car wants to move to the left. Now, it was a bit too fast and a bit too jittery, so next I did 2 things. The first is I also hooked it up so that right hand turns worked, but also you see I'm decreasing the amount that it's trying to turn from 90 degrees to 15 degrees, and having finer steps means it shouldn't jitter as much. And next I'm setting up a wall here, because I want to give it a test to see if it's able to avoid obstacles. So you can see here, it firstly detects correctly there is a wall in front of it and starts to turn, but you can see it doesn't fully turn, and is partially turning, and then still running into the wall. And this was more my fault than anything else, because what I did is I put the sensors too close to the center of the robot, and it correctly identified that the sensor had nothing in front of it, but that didn't necessarily mean the robot wasn't obstructed by something. So I'm adding in these 2 sensors to the outsides of the robot, so that if the sensors don't have anything in front of them, we can be guaranteed that the robot isn't going to be obstructed in any way. So after putting those in place, I just have to make sure to connect their outputs to where the outputs of the old sensors were connected, and then I just have to delete the old sensors. And now if I give it the same test, just have it run at this wall, you can see it still correctly detects that there's a wall in front of it, and it starts to turn. It's fairly slow now though, because I changed the angle from 90 to 15 degrees, so it's trying to move a much smaller distance in that time, but eventually it does rotate, and it barely gets out of the way, but it does avoid the obstacle. And with that looking pretty good, I wanted to start working on some of the other functions of the robot. So I'm building up a sample maze here so that I can work on that. And the first obstacle I want to give it is a 90-degree turn. Now our robot isn't exactly configured for this yet. Now if I go ahead and send the robot directly at this turn, there's going to be a few problems. And the first one, you can see here, the robot just ends up getting stuck. Now this is because the robot has no idea what's to its left or its right. All it knows is that the two sensors on its front have been obstructed, so it just gets stuck basically. So to fix that, I just need to add on 2 sensors to the sides, so the robot will be able to see open paths to the left and the right. And now I need to add in 2 more logic gates to the left and right movement, and these are just going to be OR gates. Now, OR gates turn on if any of their inputs are on. So if I connect the output of our old system to this OR gate and then have the OR gate hook up to the controller, they're just going to pass through the signal that we have before. And you can see that here. When I obstruct the left sensor, this OR gate still turns on, and when I obstruct the right sensor, this OR gate still turns on. But what the OR gate also lets us do is tie in additional systems, so if they want the robot to turn left or right, they'll also have the ability to do that. And these 2 AND gates I just put up front are going to be those additional systems. So what I'm looking for each of these systems, when both of the sensors in front have been turned on, or when something's blocking both of the front sensors, and when either the left or the right sensor has been blocked, one of the blocks looks for the left, one of the blocks looks at the right. It'll either know to turn the robot left or right, since that signals that there must be a turn. So I messed around for a little bit in exactly how to implement this, and I end up adding in 2 more logic gates, and these are inverting the side signals. So when there's nothing in front of the side sensor blocks, they'll turn on. And I have that here. So as the robot progresses here, it sees the open path, and this block turns on. And now it runs into the wall. You can see this logic gate turns on, and I'm going to have to tie in that block to the right turn so that it knows when that turns on, the robot should turn right. And here I'm finally hooking up the outputs of those logic gates to the left and right turns. And if I give it a quick test here, you can see it sees something in front of it, and the robot tries to rotate right. Now there is a slight problem, and it's that when it runs into the wall, both of the front sensors get obstructed. So the robot thinks, oh, I gotta back up now. Which usually would be correct, except here I want the robot to turn left since it knows there's an open path to the left. So I need some way of overriding that backward system whenever it tries to turn left or right when it sees an open path. So to do that, I'm using a bit of logic here. I don't want to get too into it since it's not that important of a concept, but I just get that done. And now you can see when it runs into the wall, it instantly starts turning right. Now it does it pretty slowly, but it does start turning right. And you can see here it ends up completing the turn, and everything's pretty good. So the only other thing I wanted to add in for this system, or the only thing I wanted to check, was just to make sure that it could turn left as well. And it was easy enough to do, I just had to make a left turn in the maze, and you can see that system works properly too. And it should, because it's basically just a mirror, well, it is a mirror copy of the right turn system. So now with the turning looking pretty good, there's just one more function I want to add in, and that's allowing the robot to be able to detect if it's in a dead end. So to do that, it's a little bit different than the other systems in that it's going to need to store a single bit of memory. So I'm starting off with just the trigger for this though, and the trigger is if all of the sensors are detecting something, then it should start backing up since it's in a dead end. And the reason that this works is if both of the front sensors are obstructed and the sides are obstructed, the only path for the robot is backwards. And you can see I have that gate in here, and now as I run into the dead end, you can see it activates. So now I could put in that single bit of memory to have the robot remember that it was in a dead end. And to do that, I'm using 2 NOR gates, and they have to be connected into each other, so that the output of one is connected to the input of the other. But in Scrap Mechanic, this doesn't exactly work, because if you try to make this happen, then it just deletes your initial signal. So to have this work, I need to add in 2 more gates like this and then just pass the signals through them. Kind of breezing over this because it's not the most important of details. So you'll see I started out here and these gates were oscillating back and forth. So I was a little confused by this. So I just ended up replacing one of the control signals temporarily to get it to work and decided to send it at the dead end to see if it would remember that it had hit it. And now you can see as I hit the dead end, the AND gate turns on and the pair of gates has flipped. So this means the robot has remembered that it ran into a dead end. But now if I replace the robot again, you can see I still have that oscillating issue. And I think the problem is that both of these gates, both of the NOR gates, are trying to turn on at the same time, and there's a little bit of delay between when they receive a signal and when they output one. So they end up just getting stuck in a loop forever. So to fix this, what I'm gonna need is some sort of suppression so that one of the gates doesn't try to turn on immediately, and the other one can overpower it. So to do this, I'm gonna be using a timer block. Now, if I set the timer block to something really low, like only 50 milliseconds, you can see as I press the button, how the timer block turns on just a little bit after the gate turns on. Now I can connect the output of the NOR gate and the output of the timer block together, and what this gives me is that edge rejection. So if I press the button for a very short amount of time, the AND gate doesn't turn on. But if I hold the button for a longer amount of time, or if I release the button for a longer amount of time, you can see that the AND gate does turn on. So this means that the other NOR gate should be able to turn on first before it ends up getting turned off and falling into this loop. So I decreased the time delay on the timer because I realized it actually didn't need to be as long as it was. And then I connected the output of the AND gate back into the first NOR gate so that it could trigger it again. And then I reconnected the output of this AND gate back into the SR latch. And if I send the robot back at the wall, you can see it runs into it, and it still works. And best of all, if I replace the robot, it doesn't end up oscillating. So I finally need some way to be able to reset this latch and tell the robot to stop moving backwards. And to do that, I'm looking to see if either of the side sensors is not obstructed anymore. Basically, I'm looking for if there's a path to the left or the right that the robot can turn to and go to instead of the path that ended up just being a dead end. And I'm adding in 4 more AND gates, and the function of these gates is that if the robot is in the backup mode, it's going to suppress all of the other systems we've developed, and it's just going to tell the robot to move backwards. So I have to tie in the previous systems to those AND gates, and then connect those AND gates to the controllers. And then finally, I have to connect the correct signals from the latch to these AND gates. And after doing that, if I send it at the wall, you can see it hits it, and then it starts backing up. Until it sees the open path on the left, it resets the latch, and then the robot starts moving forwards again. So this is working, but there's a little bit more functionality to add to make it do exactly what I want it to. So now I'm adding in another timer block and a few extra logic gates. And what these are doing is they're just going to delay when this latch is turning off so that the robot backs up a little bit further than it was before, since it was a little bit too close to the wall, and I think when it was going to turn, it was just going to run into the wall. So now I have that set up here, and you see as it runs into the dead end, and then starts backing up. Now it detects that there's an open path, but backs up for a few extra seconds. Here I had it going for 10 seconds, and there it was actually going back too far. So I need to lower it a little bit. So I lower that, and also decided to just compact everything together, since this was actually getting pretty unwieldy, and I was running out of space pretty quickly. So I'm not doing anything new, I'm just putting everything on this side of the robot, and now I'm lowering the delay of the timer. And after getting everything set up, you can see it runs backwards, and then starts going forwards again right when it's in the middle of that pathway. So that was actually great, but now I need some way for the robot to be able to turn after it's done backing up. And for that, I'm using another one of these edge detectors. Now this time I'm using it so that once the latch resets, it'll be able to detect that. And I set this gate up right here to detect that. So now you can see as it backs up, it flashes for a second right as the robot starts moving forwards again. So I need to be able to use this signal to continue to suppress everything and just make sure the robot turns left. So this caused a lot of other logic to be required. And I also realized I was going to need more than just one timer block, and I was going to need to stagger them so that I could effectively increase the duration of the signal. And after getting that, you can see the robot turns for a second and then ends up moving forwards again. So this was actually caused by 2 different things, and I know I'm breezing over this, but there's a lot here. So it's caused by 2 things. The first one was that I needed to store whether the left or right path is open, since once it turns, the sensors in the left and right are going to pretty erratically turn on and off just based on their surroundings. So I put another one of those gates in place, and also I was going to need more timer blocks. I was going to need to be able to stagger the signal for even longer so that I could turn for a longer duration of time. So now I'm just finishing up that SR latch, and I'm connecting the correct signals together. And if I give it another test, you can see it turns. It stops for a second there, just because I didn't stagger the timers right, but it does turn for a good duration of time. So basically the solution to this was just adding more timers. And after doing that, you can see it still correctly detects there's a wall in front of it, and then it starts turning, and the timers end up staggering it for long enough that it turns almost a full 90 degrees. It's like 70 or so degrees, but it's enough that the wall detection ends up straightening out the robot. Now there's just one other thing I wanted to do before I made a full maze for this, and that's move the side sensors in a block, since they were sticking out and rubbing against the wall. So after I did that, I made this maze for the robot to test out the whole thing, and I'll run through it here. So it starts out with this fenced in area, and with a 90-degree turn to the right, and then a 90-degree turn to the left. So it's just testing out the basic turning functions. And then it goes forwards here, and the correct path is to go left, but the robot's just going to want to go straight. So it's going to go straight and run into this dead end. Now once it runs into the dead end, it'll back up, and then see that there's an open path to the left, and then turn there. And then it'll proceed forwards, and the path to the right is correct, but it'll want to go straight. It'll run into this dead end, back up, and then it'll turn right. So it'll continue up these stairs, and this is something I actually never programmed it for. There's an open path to the left and right, but the front is obstructed. Now, I ended up adding a little bit more logic in, just so the robot biases to go to the left, so it's going to want to turn left here. So after it does that, it runs into this turn, runs into this dead end, and then it'll back out of the dead end, and go forwards here. So this is the interesting part. It'll go down the stairs, and to the right is actually the exit. But the robot's not going to know that, so it's just going to go straight, and it'll run into this gate with this piston. Now that'll end up retracting a little bit, and I'll show you. So it turns, goes straight, turns again, and it runs into another one of these open paths on the left and right. Now again, it'll want to bias to the left, so it'll turn left here, and then it'll run into this little enclave. Now it'll run forwards, and then it'll run into this sensor block, and that sensor block is going to turn off the piston that we saw earlier, and it's going to turn on another one right before the stairs. And you'll see this will allow the robot to be able to navigate into the exit. and then it'll go through a few more turns. And now it'll run into this gate, which previously had the pistons, but as I said before, they now opened. So the robot will go straight, and then it'll run into this wall here with the piston. So it'll have to turn, and here it'll be able to exit. So guys, thanks for watching. It'll probably be a long time before I make a video this long again. Pretty happy with the way the robot turned out. It actually moves pretty fluidly. There's a few points where it does end up getting into some jitters, but for the most part, it's not actually that bad. So if you have any questions or comments, feel free to ask below, and until next time.